Hi everyone, it's Miss Berlanga. In this video, I'm going to show you how to work on problem number 1 in the practice speed and velocity calculations problem set. So for this video, you're going to need to have this problem set open. You're also going to need a sheet of paper and a writing utensil so that you can work at the problem and follow along with me. Okay? All right, so let's go ahead and read over this problem. So Tiana and Tamia are working on a lab in Ms. Berlanga's class. They wrap an egg in various materials to see if the materials can protect the egg from the force of impact with the ground. The egg takes 2.1 seconds to fall 7.8 meters during the first drop. Now you guys are given a bunch of different things that you have to answer. The first 3 quantities that you're asked to give, the initial and final position, the distance the egg traveled, as well as the displacement. These are all things that you've done before, right? The only new things in problem number 1 are elapsed time, average speed, and average velocity, which at this point you should have watched the Check for Understanding video. So you should know or have an idea of like how to get elapsed time, average speed, and average velocity. But the hardest part here might be figuring out how to set up this problem. So that's what we're gonna work on. So let's go ahead and set this problem up. All right, so the first thing that we want to notice is that we are working in one-dimensional motion. So if you look at the problem, it says that the egg is dropped and then it falls to the ground. So that's just a straight line. Now, most of the problems y'all have seen before have been horizontal motion problems. So we're just going to take the same stuff that we've learned in horizontal motion problems, and then we're just going to draw a number line that's vertical. So let's go ahead and do that. Remember, this is problem number 1, so we're going to clearly label our work, right? And then we are going to draw a number line, okay? And then I'm also going to draw a flat line to represent the ground. And this is the top of my number line right here. Now, we have a decision to make. We can either put 0 at the top, we can put 0 down at the bottom, so right where the ground is at, or we can put 0 in the middle like we're used to. For this problem,
the homecoming maids are returning to class now. They should be there within the next 3 or 4 minutes. Thank you.
All right, so we have a couple of different options for how we are going to set up this number line. We could either put 0 at the top, we could put it at the bottom, at the ground, or we could put it in the middle like we're used to. For this particular problem, it's actually going to be easier for us to put it either at the top or at the bottom. Now, I like working with positive numbers, so I'm just a little bit biased like that. So I'm going to put 0 at the bottom. However, you could work out this problem with 0 at the top. And so your initial and final positions would be different, but then everything else would be the same, okay? So I'm going to put 0 right here. And then I'm going to imagine that Tiana and Tamia are dropping the egg from a building, right? Some tall structure. So I'm going to go ahead and place this tall building here. Here are Tamia, and Tiana. Okay, and then here's the egg. And the egg that they're dropping, I know it's huge, it's as big as they are, but that's fine, right? It's a sketch, so it doesn't have to be 100% accurate. Now, if I look at the problem, I notice that the egg is dropped from a height of 7.8 meters above the ground. So again, thinking about how I'm going to draw the numbers on my number line, I'm looking for that largest length or that largest distance, whatever I'm given, and I'm going to go slightly beyond that. So since I'm given 7.8, I'm going to go a little bit higher than that. I'm going to go at 8. Y'all could go with 9, you could go with 10. It's really your personal choice. I'm going to go with 8. So I'm going to put 8 right here at the top where this building is at, right? And then I'm going to finish filling out the rest of my numbers. All right, so notice that I did not fill out all the numbers on the number line. I really just put the even numbers and then I put 7 in there. So you could do that or you could fill out the rest of them. It's really up to you. Now, looking at this, I've got to start placing initial and final positions for my object, right? So I know that I dropped the object from a height of 7.8 meters above the ground. So that means that I'm going to draw a little dot just below the 8. Now this doesn't have to be perfect, this doesn't have to be exact because it's a decimal, right? So it's going to be tough for us to get it in exactly the right spot whenever we're only putting whole numbers on the number line. If you do have a whole number, obviously I'm going to expect you to put it exactly where it's supposed to be, but for this one, 7.8, just get it a little bit below the number line, excuse me, a little bit below the number 8, and that's going to be fine. Now we're also going to define a couple of other things, right? We're going to label a few other things in our problem. So this is where the egg starts. So just like always, I'm going to label my starting position, and I also want to define my initial position. So I'm going to write x0, which is my initial position, and that is equal to 7.8 meters. But notice that I am on the positive end of the number line, which means that I have to add a positive to the front of that number. So that is my initial position. Now I could go ahead and add my initial time as well, right? Remember from the annotated reading and the checks for understanding, we discussed that the initial time is almost always going to be 0 seconds. So we can go ahead and write that down as well. All right, so after this, the egg drops, it falls all the way to the ground. So I'm going to go ahead and put a dot on the number line where the egg ends up. I'm also going to add a little picture of a cracked egg just to like really visualize what's going on. So you can see I've got my cracked egg. There's like yolk just gushing everywhere, right? And then I also want to put down my final position. So I want to define that final position. So xf is equal to 0 meters. And so now that I have my initial position and final position put down, I could go ahead and start answering A, B, and C, but I'm also going to go ahead and just add in that final time. So TF, that final time, is equal to 2.1 seconds. So just like we were told in the problem, 2.1 seconds pass. Now one more thing that I do is I always add like arrows or arcs to indicate movement along the number line. So I'm going to go ahead and do that as well. Okay. And in this case, the egg dropped 7.8 meters. It moved 7 meters down. And you could also add in 2.1 seconds to your drawing. It's not necessary because you did go ahead, you added that initial and final time, but if you wanted to, you could also put that down. Okay, so now our drawing is finished and we can finally start answering the various parts of the problem. And we're going to start with parts A through C, and these are things that you already know how to do, so you should feel fairly comfortable, fairly confident in putting these down. All right, so part A asks us what is the initial and final position, and we already figured that out as part of the process of drawing our problem. So part A, easy peasy. Initial position is equal to 0 meters and final position is equal to positive 7.8. Now part B asks us for the total distance that the egg traveled. So let's go ahead and write that down. So for part B, we're going to write lowercase d equals. And again, we already know this because we labeled our drawing, right? It's very clear from our drawing that the egg traveled 7.8 meters. And that's it. And remember that because distance has no direction, all we care about is the total length it traveled. We don't care if it was up, down, sideways, whatever direction it was. All we're doing is we're keeping track of that total distance traveled. Now let's move on to part C, which is displacement. And here we do care in which direction you travel. So displacement is delta x. So delta x is going to be equal to 7.8 meters in the negative direction, because remember that the egg ended up 7.8 meters from where it started and towards the negative end of the number line. Okay, and that's it. That was pretty easy so far, right? Maybe the most difficult part of this would be figuring out that, oh, up means positive and down means negative. But really everything else was very similar to stuff that you've already done before. Now parts D, E, and F are new, right? We're talking about elapsed time, average speed, and average velocity. So let's go ahead and do part D first. Okay, so part D asks us for elapsed time, and we could use that formula. We could plug in the initial and final times, but really because we're always using the initial time as equal to 0, we can just use the final time as our elapsed time. So delta T, or just T, is equal to 2.1 seconds. Right? And now going on to part E. So part E asks us for the average speed. So here's where you need to have that science dictionary out, you need to have that annotated reading out, and we know that the formula for average speed, S is equal to D divided by T. In other words, the distance divided by time, or, as we've been writing, the elapsed time. Now notice that we already have these two quantities, right? We have distance, we have elapsed time, so we can just plug these numbers in. We have distance, which is 7.8 meters, divided by 2.1 seconds. And so our final answer is going to be 3.7 or 3.71 if you want that additional number. In my class, we're usually just going to do one digit after the decimal, but it's really up to you. Don't go crazy and put like 5 or 7 or 10 numbers or digits after the decimal, because our input numbers only have one number after the decimal, so it makes sense that we're going to have the same accuracy in our answer. So 3.7, and the units are meters per second, because the units of distance are meter, the unit of time is seconds, so meters per seconds, meters divided by seconds, okay? So this is it, this is part E. This is the average speed. Now, we also need to calculate average velocity. So again, we are going to start with the equation for average velocity. So part F, the average velocity is equal to the displacement of the object divided by the elapsed time. So the displacement, again, we already figured this out earlier in the problem. That's exactly why I had you guys do this, so that you'd be able to figure this out. Now we're just going to plug our numbers in directly. Negative 7.8 meters divided by 2.1 seconds. And that is going to be equal to negative 3.7 meters per second. Okay, so the one thing I want you guys to keep in mind is that right now we have the same numbers for both of these answers, right? So we have 3.7 and 3.7. Obviously there's a difference in the sign because velocity, average velocity has displacement. Displacement has direction, which is why average velocity also has direction. But this is not always going to be the case where you have the same numbers for average speed and average velocity. If you have a problem in which you have multiple movements, let's say the egg had hit the ground and then maybe it had rolled into a hole, maybe like a sewage hole, and it had kept going further down, it would have done multiple movements, right? So if you have multiple movements, then that means that you will not have the same, you will not necessarily have the same number for average speed and average velocity. Another example to think about is that, for instance, whenever I give you all those examples of me walking down the hall, let me find a good marker because sometimes these markers just can't stand. When I was walking down the hall in the Check for Understanding video, if I had walked 5 meters, but then I had returned, my total displacement would be 0. And if my total displacement here were 0, then that means that my velocity, my average velocity, would also be 0. Now, for this problem though, I moved 5 meters and then I moved 5 back. So my distance would be 10 meters, which means that my average speed would not be 0, but my average velocity is 0. So you just have to be careful with some of these problems, okay? Now, this is it. Let me know if you have any questions. Send me an email, and I will see you guys next time.